Hello, everyone. Hello, everyone on Twitch joining us today. I'm excited to be here today with Tim, who joins me from Berlin. Tim
I,
Falkendreff is the lead of the Python efforts for GraalVM. So GraalVM is known a lot in the Java community and for executing Java and JVM-based languages, but we're also working on a Python implementation because GraalVM's vision for programming languages and virtual machines is to be polyglot, and we certainly also want to include Python there. And Tim is leading that effort. And yeah, Tim, maybe you say a few words to yourself. Like you joined. When did you join the team?
yeah, I was literally just thinking that. I think it's just over 3 years ago now. I did my PhD also on around virtual machines, and worked on other Python virtual machines and JITs before, so that's why I was interested in that anyway. And yeah, and to one thing I've heard a lot is a bit of a confusion about what GraalPython is. So some people seem to think that GraalPython is derived from something, but it's really a from scratch, complete new implementation of Python built on the GraalVM technology. So it's a complete separate project that aims to be a drop-in replacement, but as is the case with such projects, it takes a while. Yeah, that's what they've been working on for the past 3 years.
Cool, excellent. Yes, yeah. Thanks, Tim. And yeah, so we'll now go to because you will drive this session here with live demos and coding, and I will just ask the questions. So I'm now moving to the setup where your screen is now shared. Yeah, I mean, so how do I get to Graal Python from GraalVM if I want to use Python?
Yeah, exactly. So the GraalPython right now is an experimental module. It's not complete, and if you just download GraalVM like I've done here with the community edition, and you use the Goo tool, you can list the components that you have installed. I have already installed GraalPython, and if it isn't visible there, you can just install Python, and then that's what you get. You will get GraalPython. I just already did it because I didn't want to bore anyone with the
Right.
process of watching the
Yes, and
download
it
bar.
says here stability. It says experimental, right? Which means it's
Yeah.
still considered experimental, but we do a lot of testing internally. So some Python modules, like we already tested,
Yeah.
so which are the ones that would work then?
So we have a list of things. So the first thing you'll notice is that the binary is called GraalPython,
Mm-hmm.
and that is because we're not 100% compatible yet with System Python, and many, especially Linux systems, use Python internally for other things. If you want to put GraalVM on the path, it would conflict with GraalPython, so we named the launcher differently for now. Hopefully, we'll remove that once we're 100% compatible. But you can run this g-install module that we ship, and it'll give you. So let me just run the help first. That gives you a bunch of commands to manage packages and install known working packages. And if you ask for the help on the install command, what you get is the known packages that are known to be working and that are tested in our CI fairly regularly. Well, fairly regularly, I say, on every commit. And many of these are just kind of dependencies that you might not have heard of, but some of them are kind of important, and you've probably heard of them, like things like NumPy, Matplotlib, SciPy, Pandas. Those work to an extent. Like not all of them pass 100% of the tests, but if you want to try these packages, the g-install tool is your best option to install them, and it'll pick the versions that we test. It'll pick just the exact version that you want.
Mm-hmm.
We also support the normal Python pip installer, but that won't pick the precise version that we test in the CI, because that's just not how the pip installer works. It'll always pick the latest version.
Right.
So it's recommended to use this installing tool.
Okay, cool. Yes, and I see here the kind of packages. Can you just
Oh, sorry.
this list?
Yeah.
So this is, I see here SciPy, right? I see
Yeah, exactly. Yeah, here it is.
Markdown, Matplotlib, for example, as a plotting library that's potentially interesting to use also from Java, I think.
Yeah, yeah. There is we're actually going to have a little demo with plotting from Java in this a little later. I wanted to show one other thing first. So GraalPython, if you get it inside the GraalVM, it's not your system Python. It's contained in the GraalVM. And if you were to install packages now, your choices would be to install them into the GraalVM tree or into your user directory. And both of these are kind of discouraged because if you install in the GraalVM tree, the tree isn't pristine anymore, and you can't really easily revert to the normal, to the state that it was in when you downloaded GraalVM. And if you install into your user directory, it might conflict with other installations that you had previously, because the way Python package is installed into the user directory, it only remembers the compatibility version number. And for us, that's currently, let's see, that's currently Python 3.8.5. So if you were to install packages with GraalPython into your user directory and also had CPython 3.8.5, those packages might conflict. This is true also for CPython versions. So the recommended way to install packages is always to create a VM. That is a virtual environment that it's basically just a folder. It'll create some wrapper scripts to run GraalPython from that folder and to make sure that any packages that you install are installed into that particular folder, not into your system or into your user directory. And then this way it's nicely self-contained. And this is also how you would, if you set up a GraalPython project, this would be how you would share that project also. You put everything inside the virtual event and then share that.
Right. Because this one is sort of, it's a set of packages, dependencies, and
yeah, exactly. So let's just show real quickly. So the way how you use this is now I have this folder and it has an activate script, and it says here now I'm in the GPVM virtual environment, and now actually the Python executable just refers to GraalPython. You can see here it's running on GraalVM C Java 11.
Right, because now this link was created between the Python executable and the GraalPython executable. And it shows here Java 11 as the base JDK underlying the GraalVM C, right? Yeah.
Yeah. So in the latest release, we currently ship GraalPython for JDK 8 and JDK 11. Not 16 yet, because there were some issues that we were simply just not able to fix in time for the release of 21.1. But in the next release, that's also going to be supported, or 16 plus, let's say.
Right. And in terms of Python version, we are typically in the latest, right? So 3.8.5 is close to the latest. Right?
It's close to the latest, yeah. 3.9 is the newer version. We haven't updated to that one yet, mainly because it doesn't offer many new features that we needed just yet. And there are always there's always a little bit of work for us tracking these newer Python features. So one thing we do is, let's see. Sorry. So this is a normal Python REPL. And one thing we do is we just import the standard library from whatever Python release we track, and this is mostly pristine. So we don't really have many packages that we patch or anything. We try to really be 100% compatible to vanilla Python, but that often means that as new versions are released and they add new features to those packages, we first have to test them, and from time to time also add features or inside the interpreter or fix bugs. So that's why we don't track the Python release on the day of release, and it might take a few months. But yeah, other than that, this is a normal Python REPL like you would expect. You can load things, and inside this, just to show that it works, you can also pip install things. Let's see. I think pip install igal, and I think we support 6.2.0, but I'm not entirely sure.
So this is now installing it into this local environment.
Into this local environment, yes.
I've selected it.
Yeah.
Pygal is also a plotting library.
Exactly, that's a pure Python plotting library, and it's not the version that I wanted. But that's no matter. We can switch to the other part of the demo and just take a peek here real quick.
Which version we have? Yes. Okay.
Which version I want.
Yes.
240. That's
240, right? Okay.
Yeah. 2.4.0, and yeah, but you could already tell it went to PyP, the package index. It checked which versions are available.
Yeah, this is the latest version that's not dev here, right? Yeah.
Exactly. And then it's just like works normally as you would expect. Downloads it, installs it. That's it.
Right.
I can leave that running, but what I really want to show now is get into a little demo. Oh, no, one thing maybe to mention. It says here, so this is a line that you wouldn't know from normal C Python, looking for GraalPython patches for PyGal. As I said, we try not to patch any modules at all, and PyGal we don't patch. But some of them, we do have some minor patches. Usually these are less than 10 lines of patch for just really minor things. And what we do is we hook into pip. Even when you install something through pip, it will check, is for that version, do we have a patch registered that we need to install that particular version? And it would apply them automatically. But for most of the packages, we don't need any patches, and we won't, like we will try to get rid of any patches.
Right.
Yeah. So yeah, I can show this. So now you can import PyGal. Takes a second or two. And if you do help, then you get the normal help on the PyGal package.
Yes. Okay. So we have two questions on Twitch chat already. It's cool. One question is, not all from Py are compatible with GraalPython? That's correct. Yes. We are currently not yet 100% compatible. The goal is to be 100% compatible, but currently, as we outlined, is like these are the ways to check what would work, and yeah, but not all of it works. And the second question, even more interesting, is what is the end goal of GraalPython? What would be the benefits of a regular Python? Okay, so so there is the benefits is, I think you can categorize them in two major things. One is raw performance of Python code. So in terms of performance, specifically on peak performance, if you run a program longer periods of time, Python is not that strong because it's only running an interpreter. Now here in our system, we are running a JIT compiler, and therefore if you run pure Python code, you will see speedups, sometimes really substantial speedups of 10x even or more if you run something pure Python. Now we are very good on the peak performance side of things. We are not good on the startup warm-up side of things. So it's really only good currently to use the system if you have something that is long running and not like for the small script. We are working, however, we're working to fix some of the warm-up things, and there will be new features upcoming to potentially do some snapshotting in new GraalVM releases, but that's just the current status, that warm-up is not good, but peak performance is good. Now, apart from the performance side of things, performance is interesting for some, but it's not everything. And there's a second aspect here, which is the main benefit of GraalPython over another Python implementation, is that with the system now and GraalPython becoming part of the GraalVM language family, you can now use language interoperability. So you can have, let's say, you can combine Java and Python, and we will later show this in the stream here. And you can reuse modules from other languages, and you can use all of the tooling that is available for truffle-based languages, for GraalVM-based languages, for Python. So we have some instrumentation tooling that is quite strong, and this is on the tooling side of things. Now, so there's really two things. One is peak performance should be better, and the second is the polyglot and tooling aspect. Now, these two things are nice to have, but the issue we're currently facing in development, and this is why Tim and Tim's team is working very hard to remove that one, is it's nice to have these additional things, but you don't want any regressions. So we want to be compatible. We don't want to be really bad at startup. So we want to have everything at least on the same level, on this comparable level to the Python implementation, to the regular one, and then excel on peak performance and polyglot and tooling.
Yeah, so well said. I don't have anything to add to that. But the polyglot aspect is, yeah, that's a good segue, I guess, into the other little demo that we have.
One more question from the same person. Will you support Python multi-threading?
Yes. Well, that question needs to be more specific. We already support Python multi-threading to the same extent that CPython supports it, which means we have a global interpreter lock, and only one thread is truly running at the same time, unless you're doing things like I/O or any other system interaction that doesn't run any Python code, where we can unlock the GIL and then run in parallel. But we do not support multi-threading currently to the level that Jython, for example, did, where they really run the threads in parallel. One reason for that is Jython never supported Python C extensions. Jython never supported NumPy, for example. And we want to support this, but C extensions have a lot of global state, and they really expect to be run basically exclusively single-threaded, not multiple threads interleaving. Many of the functions in Python C extensions aren't written to be reentrant. And it is more difficult to come up with a good scheme to allow truly parallel execution and still support all the C extensions properly. We are thinking about this, and there are some ideas that we have to make this work better for parts of the Python code. So things like you could imagine that when you're just dealing with pure Python code in one thread and then a C extension in another thread, and these don't currently share any objects, for example, because they're working on different things, then we could parallelize this. And we are thinking about this. It's just right now, our highest priority is really to get these the compatibility with these C extensions up. And so this is the true multi-threading, true parallel execution is slightly further out.
Right. Cool. Yeah. So we do support the global interpreter lock multi-threading like standard Python, but and you might experiment in the future with more. But there might be restrictions on maybe some C extensions or some certain modules might not be available.
Yeah, exactly. Yeah.
Cool. All right, let's go to you have your GraalVM Python Java example.
Yes. I'll run it first, just so people can see what this is all about. And always takes a little.
This is a PyGal example, so it
this is a PyGal example.
It will be graphical.
Yes. I'm just waiting for the. Here we go for the. Come on. Okay.
I see it.
So can type a function. It's rendering the function, and here we were talking about warm-up and start performance, and so I put a little bit of logging in here, how long this took.
Right.
So the actual rendering of this took 5 seconds. So this is the very first time. So this is actually included loading PyGal and doing the first run and doing the first render to an SVG, and the SVG is then rendered onto this Java canvas. So this is a normal Java.
It's a Java application, a JFrame swing canvas, and now we have used the Python plotting library within our Java application.
Exactly. So if we run this again, now this only took 1 second, and so you can already see the JIT at work. I don't know. Let's do like something slightly more interesting, maybe. So 1.2 seconds, something new. And yeah, as we keep going, this thing will improve to like earlier I had it to, after like 10 or so renderings, I had it to down to 0.2 seconds per render. So yeah, you can see the JIT in action, and you can actually hear, let's see if we can see this in HTOP. Yeah, you can see here's GraalVM compiler threads running. And this is because as we render more and more and repeatedly, more and more code gets hot. And so there's more and more compilations going on. Then now it's all quiet again. The compiler has compiled everything that it figured is hot right now. So, but this keeps going while we execute this. And you get to a point where it just never compiles anything anymore. And this is also something that we're working on, is that if you have an application like this, you run it a bunch of times until nothing compiles anymore, because then you've reached peak performance, and then we just kind of keep it at that and wrap this into an application, including all the compiled code, and then just fast from the start.
Yes, exactly. So currently it's always warming up when you start it. We're working on something to then allows you to snapshot the current state, so you'll be fast from the starting point.
Yeah.
Cool. But yeah, now actually I think it should be better now, right? Because now we are not competing with compiler threads anymore much. Can you draw this again? Just to
sure.
Exactly. Now we're already down to 0.5 seconds, because that's the other thing you need to consider. It's not just that the fact that the code runs slower, but if you have compiler threads in the background still trying to catch up with the application, like they will compete for CPU and memory cache resources.
Yeah. And you can already notice this actually right now when running Zoom, because Zoom takes 2 of my cores generally. And so you can actually tell that it takes slightly longer to reach that peak, because it's slightly longer to render, to compile everything.
Yes. Yeah, cool. But this is like showing basically now with the GraalPython system, you can now in your Java application, for example, embed a certain plotting or use a plotting library from Python and embed this in your application, and you don't need to do any management of different processes or sending around SVGs or anything like that. It's because it's all in one application.
Yes. Yeah. Okay, so let's dive a little bit into the code for this. This comes up fine. Yeah, should. All right. So let's first see how this is, like how the application is set up. So this is using Maven. Let's not install all of these things right now. And this is an example project that we plan to make available in some way. This is why it also has a lot of comments, so to kind of explain to people how this all works together. So this Maven project ties together all the Java code and some Python code, including the Pygel package. And as I've shown before, the best way to ship, to bundle a Python project is inside a virtual env. So simply what I did here is, as part of the Maven definition, there's an execution where we say, okay, we're going to prepare a virtual environment. We just run the GraalPython executable and create such a venv that's already visible here, and we install the required packages. So this is kind of a nice template that can be used for any of these kinds of integrations with Java and Python. You can just create a venv and then install the packages that you want, and then they're just available. And these are then just as resources just included in the normal Java resources inside the class path or inside the jar, whichever way you want to package them. And then also one other thing to note is this GraalPython integration, this really needs to run on GraalVM. This isn't a drop-in for Jython. This is meant to be a drop-in. GraalPython is meant to be a drop-in for CPython with added benefits, but it's not to be meant to be a drop-in for Jython. Jython you could just run on any JDK, and this is just not something that we plan to do, because we want to take advantage of all of these polyglot features that GraalVM offers with all these other languages. So also one other simple rule I did here is this thing checks that the Java home is set to a valid GraalVM rather than any Java.
Right. But I mean, you could still, I mean, GraalPython is still a replacement for Jython, right? Because
it is a replacement. It's just
it will require you to use the GraalVM based distribution of OpenJDK. Yes. Because I mean, this is in any scenario important, because you want to kind of have the JIT compiler and all of these things inside. So but in that sense, it is like GraalPython is a replacement for Jython, I would say. It just requires you to also use the GraalVM based OpenJDK distribution.
Yeah, I probably should have said it's not unlike with CPython, we're not planning to be a drop-in fire and forget replacement. There's a little bit of work you need to do, and that is download the GraalVM OpenJDK rather than.
Yes, and also our APIs are a little bit different. I mean, the Jython APIs haven't been updated for a very long time.
Exactly.
The GraalVM Polyglot APIs are much more sophisticated, have more features in there. because they are newer and under much more active development. So yeah, I mean, we have actually, I think you have a migration guide, right, from JSON to
we do. There's a on the GraalVM blog, we have a blog post that explains some of the differences in more like a readable style, and then also inside the GraalPython distribution, there's documentation that's also on the GraalVM org website that just shows that goes through all the features from JSON that we support. And I'm actually going to go through some of those migration.
Yes, and this is, by the way, another benefit that I forgot kind of something like GraalPython over CPython is that you can use it like you would typically use JSON, where you have a core Java application, and then you want part of it to be scriptable. And in this scenario, you can make it scriptable with Python. So you have a platform, and then you embed things inside. Where we use this at the moment already is, for example, when we have JavaScript in the database, where we have then JavaScript embedded in a core platform. Or we have the NetSuite Oracle product that allows you also JavaScript to customize it, and that JavaScript is running on our JavaScript GraalVM implementation. And in the same way, you can here now use Python to make your system extensible. And we are currently working on making, for example, Python also available then in that database setup, and maybe also in the setup of our other systems that are like customizable by users.
Yeah, exactly. And this example is actually kind of built in a way to show, supposing you had an existing Java application with a little bit of interfaces and a bit of framework around it, and then now you want to replace some of that with Python code because you want it to be more dynamic and more scriptable and more accessible to the user. So let's get through this. Look,
I'm just loving it. You allow all access is true. Yes, I think that's the practical developer view. I think security experts, if you have any listening in, will be not delighted by a default of allowing everything. But yeah, so in general, when you create the context, right, you can set limits. By default, our default actually will be that limits are set. Right?
I was actually going to talk about this a little bit. So we can, if you want, we can play around with this a little bit. So let's allow all access false right now.
Right.
And it'll recompile and should just be here. And immediately we get an error because, well, this option is experimental, just like Python is. So the first thing we need to do is allow experimental flags. Right. Okay, so let's allow experimental flag options. Sure, right, let's do that one and see how far we get. Once again, and there is a lot of things, surprising number of things that fail, and there's a long stack trace. Unfortunately, we need to make that better. So here's a security exception. This operation is not allowed.
So we need a file access.
Exactly, file system access is currently forbidden, but we are using a virtual environment with Python files in it, so we need to allow I/O. True. Okay. Then the next one is going to be also interesting because that's not something you always think about when you run Python. When you run, so I chose PyGal because it's a pure Python package, and you would think that, oh, it's only running Python code. But here it says, oh, I cannot run any C extensions because native access is not allowed. Right. So what's that about?
Yes, because native access can give you access to, a lot of things.
A lot of things, yeah. And so the thing, the issue is, and this is actually been fixed now in the master, and will be fixed for the next release. Pip loads enough packages, and it loads one C extension package by default, always. So whenever you have with pip installed some package, it will very likely cause some C extension to run. That's a bit unfortunate. We don't like that, and we've in the master we've now integrated a very, very small patch, really just 2 lines of code, that will in the next release allow you to just run it like this with just these permissions. But for now, because I'm running on the 21.1 release, we're going to have to allow a few things to get.
Right, because we want polyglot access, we want access to other languages.
Yes, because so we need native access because we're loading native code. We now need polyglot access because our native code is running through Sulong, so the GraalVM LLVM interpreter. So we need to interact with that using polyglot API. And I'm also just going to skip a few more things because...
Right, we're allowing to create processes. Why do we need to create a process?
Why do we need to create a process? Because unfortunately, and this we also fixed with a little patch, unfortunately in the Python standard library, there's a module called platform that can be queried to ask which platform you're on. And the default implementation is it spawns a sub-process to ask. And that is a bit unfortunate. So we patched this line to find out which platform you're on differently, because you don't want to allow creating processes all the time.
Right.
And the last thing we would also need is a class host lookup.
Host class lookup, because this is the way we can from Python access Java code.
Exactly. And this we actually always are going to need because of the next thing that I want to show. So this create PyGal renderer it's using the context API to create something, but what it does is it evals some Python code that we just get using the resource stream, because as I've shown in the POM, we copy all the Python code into the resources folder, and then so what we get from the SDK API from GraalVM is a value, because Python objects are dynamic. They could be anything. They're just they're values, right? You can ask them if they're executable instance. But for a Java integration, it would be nice if they adhere to some interface. So there's this method on values as, where you can basically cast a dynamic object, like Python object, to a Java interface. In this case, this graph render interface. And the graph render interface is really just very simple. It's something that can render a function with a certain amount of steps, so points, and then returns an input stream. And the input stream is supposed to just return SVG data.
Right. But here, we have to define this API somehow, right? But we are calling here a Python function. Can you show the Python function that you're calling here?
Yes. You mean
this one, right? The def render, right?
Yeah.
Yes. So this is the Python function, right?
Exactly. So this, it also says in the comment, this is meant to be used from Java using the graph renderer interface. And the graph renderer interface says you have to define a render function that takes a function parameter and steps. Python is untyped, so we just have to, usually you would probably just have to document that this is supposed to be a string and this is supposed to be an integer according to this interface. And then the other peculiarity, of course, about Python is that even instance methods always take explicitly the self parameter. Right. So that this in Java. But then other than that, this is just mapped to this graph renderer interface function. And this is what we've seen printing. It says rendering a certain function with a number of steps, and then it printed how much time it took. And really all it's using here from PyGal is this chart that it says, PyGal, please create a line chart with this function and render it. And PyGal always returns SVG data. Right. Now, the other thing that the graph renderer interface says it's supposed to return a Java IO input stream. And this is an abstract class. This is not an interface. And the interesting thing here is interfaces in Java, you can create proxy objects that just proxy the interface definition to these Python objects. But input stream is an abstract class. So you actually need a Java object that actually inherits from input stream to return here, to be compatible. So what we do in Python is we actually subclass Java IO input stream. And this is why we need to put permission for a host lookup. So this is another feature that we implemented to be as compatible as reasonably possible with Jython. You can just create Python subclasses from Java classes. And because input stream has one abstract method, the read method, we need to implement this.
Okay, now, why are you doing this input stream? Why are you not just converting this to a string and returning the string?
I could just return it to C. I could just do that. It's
it's
more part of the example. It's to show off this subclass.
To show off the example. Okay. Just
it's
the
simple version would
be
be
string. The simple version would be just to the string because it looks a little bit scary.
Yeah. The interesting thing I wanted to show with this one is so input stream has this abstract read method that's supposed to return. It takes no arguments. It's supposed to return the next byte. But there's two other read methods. One that reads into a byte array that's passed as an argument, and then that reads into a byte array at an offset and to only a certain number of characters. Now this is used in Java. This is just overloading, right? Based on the argument types. But in Python, we don't have this typing. So if we implement this read method, it will override all of the input stream read methods. So this is a bit of an unfortunate side effect of combining a completely dynamic language with a statically typed language, just like Java. You have to now implement all three variants using
we're using the length argument, right?
Yes. But yeah, this is just like one thing to be aware of, and that's also the reason why this is in this example, because it's a common pitfall that might surprise people, and so kind of useful to have it in here.
Right, because Java has method overloading and Python
does not. Python does not. Yes, and of course, probably you would want to then factor this out a little nicer and just call a different method here and not have. But for simplicity's sake, this is here. So this is why we need this below class lookup. True. The other thing, so somebody was asking about the threading, and this is actually already running multi-threaded because this runs Python code on the Java main thread. But when you render something, we actually just render on the input on the AWT thread for input events, for handling input events. So Python is actually using two different threads. It just happens to be that these never interfere, because after loading the code in one thread, it's all been driven by the event thread. But this is kind of interesting to know that this render object, this graph render object, which is really a rep Python value, this can flow into different threads. That's no problem, and it'll work as you would expect. And if the other thread were executing, it would transparently interact with the other thread to take the global interpreter log and run, and then release the global interpreter log again. So there's nothing that the user needs to be aware of this. Right. Let's show another thing here. Probably should have just kept this open. To kind of show, what did I do? Right. Let's just go. Yes, let's just go back for development time. Yes. It says here that you should really do that.
Okay. The default action. If you have too many permissions, just allow everything.
Yes. Well, and for development, it's kind of useful because you kind of sometimes during development you don't yet know which packages you're going to need, right? Which packages you're going to put in, and you don't want to every time you try a new package, you don't want to have to figure out what other permissions do I now need, what file system mapping maybe. So you really, you don't want to have to slow down development during that time. But before you deploy it, you should. So let's run this. And we get a zero division error. And one nice thing that I wanted to show here is you get this Java stack trace, right? In the event queue, dispatch, and so on. And then it actually gives you the Python stack trace on top of the Java stack trace. So you immediately know where this problem is. And you don't kind of have to figure out from the Java stack frames where in the Python code that might be. So this is kind of nicely mapped. So it's in this PyGal renderer Py file that we've been looking at line 27, because what's going on here in line 27 is that the string that's passed, we just eval it So that's another reason why you should lock down the permissions eventually, because this is just evaluating arbitrary code.
Right, of course.
And what it does is it evals everything for x value, the function for x values ranging from -100 to +100. So null is included in that. 0 is included in that. So,
but in general, this context execution from GraalVM, it's trying to have this permission-based system, so you can execute less trusted code, and we have things like, for example, preventing infinite loops as well, or like infinite resource consumption in such scenarios. Where like you want to have something that's embedded and that's different from your outer system.
So for simplicity's sake, I'm just gonna catch the zero division error and just say that we define that as being 0. All functions at that point are then 0. And now I need to compile again, because this is now a resource change, so the resources in the jar need to be updated, and the VS Code thing doesn't do this for me. Of course, the other interesting thing maybe about this real quick is that we can, using the eval, we actually include some more globals, in this case, the math module, which is why something like the sine function actually works as you would expect, because by default, the sine function isn't a global Python function, it's only defined in the math module. But you can, in a proper application, you would probably check this string before evaluating it. So here's my application again. And now we can render something. And this is what we were talking about earlier. If we could have saved the JIT compiled code already, it would already be hot now, but it isn't now. But yeah, so now we can render functions that have undefined places because it'll just treat them as 0. And can go crazy. And
all right, the mathematicians in the audience are gonna.
I know.
It's a computer scientist here. There's an error, just return 0, should be okay.
And there's to the power of -200 just to show that it's like we can deal with big numbers, no problem, and very small numbers also. It's fine. Of course, not all big numbers, because this one cannot convert to integer. That's infinity.
Right.
Okay.
Yeah,
okay,
infinity,
cool.
Isn't infinity maxint?
Infinity should be defined as maxint, but when you're converting it to Java integers, then Java doesn't agree.
Doesn't agree. Okay, good.
All right. That's this example. As I said, we're gonna make this available as kind of a template for people to get into combining Raw Python with Java applications.
Cool. Yes. So this is here. Yeah. So we talked about Warmup already and things like that. So yeah, like can we just quantify a little bit, like how bad is it?
How bad is Warmup?
Yes.
Quantify it.
So how many seconds? I think it's like typically after 10 seconds you should be okay. Right?
Yeah, typically you should be okay after about 10 seconds. With an interactive application like this, you don't even notice it so badly because you're doing something, then you're probably looking at the output, and during that time it's still compiling, so you're kind of cutting it down. You notice it more with larger applications. Generally, of course, the more code you have, the longer Warmup might take.
Right, yes. So the warmup is a function of how much code is taken.
Yes.
And in terms of peak performance, do we have maybe some short, really numerical stuff where we can show our peak performance?
Sure.
Something sophisticated like Fibonacci.
Something like Fibonacci. Sure. Let's just create a little.
Because I think because you show here like the Java Python interoperability, and this is really cool. But I think for pure Python code, you also have advantages here.
Okay. You're asking me to write a Fibonacci now, right?
Yes.
Okay.
Yes, just it.
Lib and return. Oh, God damn it. I have created an Alpine Debian thing for this, and you're asking me to type without any.
You can use the Visual Studio Code.
Yeah, but I really don't trust it, right? If n equals 0. What? How's it defined again? I literally forgot.
It's
Return one, right?
Return
Yeah.
one.
Yeah, that's the thing. Let's return. God damn it. Sorry, I shouldn't swear. n-1 plus n-tau, was it right?
Yeah, I will cut it out of the string.
And of course, we should probably run this with something. I don't know.
Well,
I think 100 is pretty large.
Yeah. But you need to also return 1, I think, if n is smaller equal 1.
Oh, right. Yeah, because obviously, yes. Okay. So this is
100 is too high, I think. I think it's too high.
Yes, I know. That's going to take forever.
No, do like 10 max.
Yeah, let's do 10.
Let's check if 10 even works with the regular Python.
Yeah, that's I wanted to check that one first, and I don't have time. And -v doesn't work. And so 10 is fast.
10 is fast. All right, then let's go up there.
15. Let's go up to 15.
No, I don't think it's a deal.
Wait. No. Print this. That's not right.
Yes.
That's not right.
Especially.
This is even VI. That's not even Vim. Oh, God. That's printing something. Wait, that's too small. That can't be right. Oh, it's
probably correct. It's probably correct. Yes.
Is it?
Okay. Maybe not.
No, that's too small. And I really can't type. There we go. It's going to take forever. $150 is just too large. That's way too much. Okay.
No, way too much. This is.
Yeah, I know. I know.
This is.
I really have no idea how long this is going to take. So I'm playing with this. 5. And that's not 2 seconds. 2 seconds is still a bit. 55 way too large. Let's do 40. 2 seconds.
Yeah, no, it goes up really high, like very fast.
Yeah, I know.
So what was the one with 2 seconds?
It was 35.
Okay, then 236.
Okay. Uh, 3 seconds is still okay.
Let's just try our stuff.
Let's just
Let's start this. I think we will probably be slower here, substantially still, but let's see.
Yeah. Let me just move this thing out of the way because I have controls there.
And we need to time it as well.
Yeah. So this is 1 second.
Oh, we are already much.
And this is I mean, I would expect to be faster, but that's probably still taking. Let's see if we have CPU sample. It's probably still taking. Oh well, it's 90% of the time it's running compiled code. So this is one of the cool features, like the tool.
Right. So in this scenario, if you have an app that is but now let's try a smaller number, substantially smaller number. Let's see at which number we are getting here. Yeah, 26 is good. So on 36 with the 3 we have like 1 second, which is 3 times faster than the 3 seconds from the Python. Yeah,
and here we're 10 times slower, and you can see we're only running 30% of the time in compiled code. So we 70%, like 65% of the time, we spend not only running it interpreted, but also competing with the compiler thread to run this code. So because
we're spending all the efforts to try to compile it, and then in the end it didn't even matter.
Doesn't pay off, exactly. It's for this small workload, it might have actually been faster to just disable compilation. And there's an option for this, but I forget what it was. Maybe we can help.
Yeah, let's see what options we have here.
expert or something?
So interesting. Actually, let's just talk a little bit about these options here, because I don't
Okay.
think it's like before the stuff you saw before, just the regular ones, right?
Yeah. Okay. Let's go for the normal.
Yeah. So because some of this is like maybe obvious to some of us, but it's not.
Okay.
So this is the runtime option. So there's minus polyglot, which is already interesting. So this is relevant if you want to enable other languages on top of Python. Right?
Yes. So we can try this out. So there's this polyglot module, and it's very interesting. The interesting thing is eval. You can eval something in a different language. So,
right. So for example, JavaScript, let's say.
Yeah. And language.js and language. Sorry. Language. And now it says, okay, JavaScript is not found, right? Because I didn't run with the polyglot
flag. Right?
Flag. And I'm just going to run with the JVM flag. I'm going to explain why in a second. But import polyglot and JS, and now we can run it.
And now we suddenly have JavaScript available. So it's not only possible to combine here Java with Python, but also Python with JavaScript, or Python with Ruby, or Python with R is a very interesting use case as well. Given that we have an R implementation and both are in the data science space. So if you write a Python program, for example, but then you really need this one R module, with our system, you can get that.
Yeah. And so the other flag I just added sneakily is the JVM flag. And the reason I added this is because Thomas, you want to say?
Yeah. I mean, typically the native flag is the default, I think, right? It's just running it regular. And then, but in that mode, you do not have access to dynamically loading Java and running Java code, and you're not running in the hotspot JVM. With minus JVM, you run with the JVM with hotspot, and now you have access to all of Java. So minus JVM is sort of, it is opening up the Java aspect of it. It actually means that the startup Warmup is a little bit worse in the minus JVM mode, because we need to set up the whole JVM, and there's additional startup overheads to that. In the minus native mode, the GraalVM compiler and truffle and all these things are already pre-compiled. So that's why native is also the default and closer to what you typically want, except if you want access to full Java.
Yeah. And I added this in this case because the native Graal Python launcher, because we in this translation to native code that's using GraalVM native image, it does an analysis of all the Java code that's actually needed and only puts that into the image. And by default, if you're running Graal Python, you don't necessarily need JavaScript. So we don't have that in that normal native image. So I use the --JVM flag to allow dynamically loading the jar file of the GraalVM JavaScript implementation, and so this is why it was available. But of course, it's completely possible to just use GraalVM native image and build native images that just simply include multiple languages, and then this also works with the fast startup and with the fast warmup that native image affords.
Cool. Okay, cool. And then there's other options here. Maybe we do -1 helps tools here. There's tools options.
Yeah.
Okay. So
there's a lot of them.
A couple tools that are available to you, and this is what I talked about as well earlier. Is like when you run Python code here, we can do tools. Does the code coverage work?
The code coverage works, but I'm not sure what it's going to print for this small.
All right, let's do it.
Well, let's do it quickly, because I think you see something.
Just do -1 coverage. It should be fine, right?
-1 coverage should be fine. It probably just outputs,
Yeah, so this outputs, we hit everything in fib.py. We need to add another function to make it realistic. Add a second function that's not the hit.
Yeah.
Just copy the existing one. Just copy the existing one and do fib2. Okay, let's save that.
Here we go.
Yeah, so
And
now we see in the fib.py function, your statements executed is only 66%. So this is the code coverage. This is, by the way, a language agnostic tool. We choose the power of the GraalVM platform. In the sense, we wrote this tool only once, and it's the same tool that processes here JavaScript, Python, with Espresso also Java. So these are all language independent tools.
I just want to show something because it's kind of neat. Sources. This is how much Python code is actually loaded just for this fib.py, because during startup there's a lot of Python code already running, right? It's already examining your system,
right,
which other packages are available. So you can actually see there's a lot of Python code running before fib.py is even loaded.
Yeah,
because
this is really cool because now suddenly I see exactly which parts of the standard library are executed by my Python program.
Yeah. So you can see that by default it already looks at the encodings because it checks what file system encoding, default encoding you use in your system. So it's already doing that.
There's these 3 columns. Can you go to the top to see what these 3 numbers mean? Oh, this is statements, lines, and roots. So statements, okay. It means programming language statements. The other one is counting probably empty lines as well. And roots means the number of functions, I assume.
Exactly, the number of functions, and each module file itself is one big root. So that's why in the fib we saw coverage of 66%, even though we only had 2 functions, but the module itself is one function itself. It's like a function, it's a root in and of itself. So 2 of them were covered because it loaded the module and ran the one module and it ran the one fib function, but not the fib2 function. So yeah.
Cool, yes. Okay, so we got here code coverage, tools integrated. What else we have in terms of tools there? Can you go into the help tools? There's a mem tracer, memory tracer could be.
Mem tracer also works.
Let's run that one.
Let me move this one here. Let's run it with an expose internal because that's just
because
makes it more interesting.
Yes, our Fibonacci is not very interesting because Fibonacci is a very bad benchmark. Just to make it clear, we're just making fun of the Fibonacci benchmark. We don't think it's in any way.
It's really not representative of anything.
yes, exactly. So if you see any performance comparison, you see a Fibonacci there, you know it's not the right thing to do.
Let me pipe this into less because it's just too long. So here we see allocation counts.
We have a binary sort here, interesting enough. So there's a binary sort that's pretty heavy on allocations.
Yes, because this is also another reason for that we're working on for our warm-up is that some parts that in C Python are implemented in C, we still implement it in pure Python. This is an artifact of that we sometimes want to move fast to bring compatibility up, and then we convert this later into intrinsic code. But our entire sorting for lists is written in Python, in pure Python. So that's why it creates a lot of objects, and is also, if you just benchmark the sorting, it takes a while to be as fast as C Python.
That seems a low-hanging fruit for Warmup
as
well, right?
Because especially as you can see, even doing startup, it does it a lot.
Yes, it's obviously the hottest memory. Yeah, so can we do the CPU tracer, actually? Let's do the CPU tracer with all of this. And yeah, this expose internal sources is a flag I didn't know before. I should have, when I was playing around with this. This is very cool, so you can get all of the... I think we should document that a little more prominently, because this is very interesting. All right.
Yeah, you can see here that the fib does take the most time in this benchmark because we sized it. But just right after that is in the sorting.
Yes, team sort.
It's not. It's team sort. It's not named after me, right? It's the team sort algorithm. Just in case somebody's wondering.
Exactly, that's right.
It's not vanity. But yeah, it's actually taking a lot of time, right? It's right up there.
It is the main thing to do here, right?
Yes.
And this here, okay, so this is now the counting, right? This is counting the number of times. I don't think it's timing it, right? It's
No, it's just counting the number of times this element was executed. It's really, this is the tracer. It's really counting and not sampling. Before we were using the sampler that does like every millisecond or so, something. And this is really counting, so this is precise. But of course, that implies a little higher overhead also in the execution time.
Yeah, I think this is one. Yeah, but this is one interesting aspect here. Is like one of the ways we do here the sampling tracing is to do counting statements, which is more predictable than let's say CPU measurements. And when you do performance optimizations, etc., sometimes the absolute number is not that important, but the relative number and making that relative number predictable is important. And that's why I like this kind of measurements here, like that are really should be 100% predictable. Let's run it again, actually, if it is 100% predictable.
Okay, let's remember some of those numbers.
Here, we will see the numbers. Yeah.
So interpreted and compiled changes, but that's expected.
Yeah,
the total didn't change.
But the total didn't change. That the other thing changes because we have background compilation on. Meaning the compiler is another thread, so it will depend on how fast the compilation finishes, but the total count is 100% predictable. And that's interesting because, for example, if you have a CI/CD system and you have a certain Python method that you think is really important to not like regress on, you could put it to your CI something that is then gated on the exact number of statements that this method is used here, and you will be notified immediately if that would change.
Yeah, exactly.
So this is why I think that's a very interesting tool here as well. And yeah, in general here, like all of the Truffle, or most of the Truffle language agnostic tools should work here now also with Python, and makes it interesting to play around with using here GraalPython maybe in your CI/CD pipeline, for example, for your Python application, or so to have access to these tools. Very cool. Yeah.
Yes, and in fact, some of the built-in tools. So CPython comes with a built-in standard library profiler, and we map this automatically to the GraalVM tools because the GraalVM tools are actually written to be lower overhead than what CPython offers in terms of profiling tools. So this is just like a value add for us.
Cool. Yeah, so we are top of the hour. So do we have any more questions on the Twitch chat that I can ask Tim, or I can answer myself? Yeah, so we will as usual we will upload this video later, also for anybody who wants to asynchronously watch it, or if you want to share it with anyone.
Yeah, and as I said, the code, we will make that like little example program available.
Yeah, we'll publish the example program. There will be another tweet, probably we'll tweet about that one. And yeah, you can reach out to Tim or myself on the GraalVM Slack channel.
Yes, there's a #GraalPython channel.
Yes. All right, cool. Yes, okay. Thank you everybody. Thank you everybody for listening here, and specifically also the ones that brought in some questions to the Twitch chat here. Thanks Tim for preparing this demo and having the session with me here on GraalPython. I'm really happy to see GraalPython getting real. It was like very, very experimental 12 months ago, and now I can see, yes, this is starting to be real. And so we actually like to ask the community to give us feedback on this, try it in the system, so we can improve it, and then at some point feel comfortable to remove the experimental flag from this part of the GraalVM system. And yeah, I'm really excited about this Python and having now Python, not only the Java and TVM-based languages on GraalVM, but also Python running there.
Yeah.
All right. Cool. Then thank you everybody. Thanks everybody for listening. Thanks Tim, and have a great day. We will be back next week with streams again, probably on both days. I think Oleg will stream and myself will likely stream as well next week. So yeah, stay tuned, and thanks everybody.